Hello, this page is a continuation of our page 19 and 20 in our packet. And this problem that I'm showing you right now is not in your packet. I just wanted to start and demonstrate 3 different ways you could show your work on this type of problem. All right, so first of all, if we look at the variable is being divided by 5. So we're going to do the opposite of dividing. So when I build my wall, I have choices. One of the choices is, since this is divided by 5 and it kind of looks like a fraction, I can show my multiplying by 5 as a fraction. And on this particular side, because this looks like a fraction, I can show this 5 looking like a fraction. However, on the other side, it doesn't look like a fraction, so I can go ahead and just show 5. So if I did this, I would multiply straight across, and I would get 5n divided by 5, and on the other side I'd get 35. The nice thing about showing it this way is it's now clear that this is 1. 5 divided by 5 is 1, and that allows us to get n equals, 35. Okay. So that's the solution. And if I wanted to check it, I would go to the original equation. I would replace n with 35. I would divide it by 5, and it gave me back 7, which is the original equation. Then I know that my answer is correct, and it is. So there's a couple different ways we can show this, and that's just what I wanted to demonstrate on this. So let's move to the next. It's identical problem. This time, instead of showing 5 as a fraction, I'm still n divided by 5. So the opposite thing I'm going to do is I'm going to multiply by 5. I'm just going to show it next to the n. So I'm multiplying 5 times n, and over here I'm multiplying by 5. As long as I'm doing the same operation, then I'm okay. Again, if I look at it this way, this kind of cuts out that middle step on the first problem. I can say 5 divided by 5 is 1, and 1 times n is n. Then 7 times 5 is 35. Now I'm just placing this next to the variable just so it's clear to me that 5 divided by 5, this is what I'm kind of going after. But we don't have to show it that way. In fact, let's move to the third way. Once again, this problem is n divided by 5. So what we want to do is we want to multiply by 5. So just straight ahead, we can take 5 and multiply it times the the left side, and we can take 5 and multiply it by the right side. We're doing an opposite of division. As long as you're showing that you're doing the opposite operation, we're in great shape. And so that's what we've been doing each time, whether we take it as 5 as 1, whether we replace it or place that 5 next to the variable on top. We're doing the same version of the same thing. So as long as this is clear and you're comfortable with the fact that the 2 5s indeed are opposite operations and they cancel each other out, you can use it this way. It doesn't matter. So whatever way basically helps you and makes sense to you is the way that you're going to use it. So now let's apply it to the integers. Would you please turn to page 20? All right, let's read the directions. It says the second half of this assignment is working with integers, and it asks you to show your Murphy-Dillon or the Margar faces next to the problem to prove that you know what the correct sign of the answer is. That's the only added thing we have to watch out for when we're doing this particular assignment. So when we start, you can choose whatever way you're going to show me that you know and understand that this is division, and so you're going to choose to multiply. So this first time around, I'm going to multiply by a fraction. I notice that the integer is -4. Because I want my variable to be a positive variable, I have to use that same -4, because a negative divided by a negative, or a negative times a negative, would be a positive. So I need this W to be positive. So if I multiply by negative 4 on the left side, then I need to multiply by negative 4 on the right side. So what happens is when we go straight across, negative 4 times W is negative 4W. That should be an arrow. And 1 times negative 4 is negative 4. On the other side, and this is where you need to show your face, a positive 6 and a negative 4 is a negative. So I have negative 24. And so now I can prove, again, with using my face, I have a negative 4 divided by negative 4. This is a positive 1. And now my W comes down as positive W, which is what we want, equals negative 24. So I follow the directions. I showed a face for my side that shows the answer, and I showed a face for the side that proves that I have a positive W. So let's look at the next problem. Let's look at H. This time I see that N is being divided by positive 9. So again, I want to have my variable be positive. So I'm going to multiply by a positive 9. So if I'm going to this time choose to show the 9 next to the variable, and I'm going to choose to show the 9 next to the negative 2, so I'm multiplying. And over here, since I had a positive and I'm multiplying it by a positive, I am going to get a positive variable. What happens is I have positive 1, that drops down my variable of n. 1 times n is n, using the identity property. And on this side, again, the request was to show the Margar face. I have a negative 2 times a positive 9, and that's going to be a negative answer. So this is going to be negative 18. So if we want to prove, if we're not sure that our answer is correct, I'm just going to go back and do what's called a check. I would take my original problem, it's buried in there, it's n divided by 9. So we think that n is negative 18, so I'm going to divide that by 9. And the original problem says it should be negative 2. And if this is true, then I know my answer of negative 18 is true. And this would be true because I have a negative divided by a positive, and that would give me back a negative. Okay, last one together. Let's go on to I. I'm noticing that A is being divided by negative 3. So if this is a negative, I have to use negative 3. If this number would be positive, I would use a positive 3. So whatever we're doing, the opposite is not the opposite integer. The opposite is multiplying. If I see division, then the opposite of that is to multiply. So I'm going to multiply, and again, you can choose whatever way, the fraction way, whatever way you prefer. I prefer to write it next to the variable. Side by side is multiplying, so I'm going to write this one next to the number on the other side. There's my wall. Now, if I think about this, I'm going to show my Margar face. I have a negative divided by a negative. She's all the way asleep, so she's happy. So this is positive 1a, and that's how I'm able to isolate the a using the identity property. 1 times a is a. And over here, I have a negative times a negative. Again, she's all the way asleep, so she's happy, and we get a positive 24. So would you please complete J, K, and L, and then please turn that in. Show me a picture of your work, and thank you for listening. Bye-bye.